Hello, everybody. Thank you so much for joining us. This is actually the last session of the Sustainable Project Delivery webinar series. I'm Jansen Moon, an architect at headquarters USACE, and I will be emceeing today's session and supporting as we go. So today we're going to do something slightly different outside the normal format. Today uh, we have Helen, Hoang, and Othniel Williams from Sacramento District, and they'll be presenting their research on resiliency from their time at Searle. So, resiliency is one of the hot buzzwords right now in the current administration and across the DoD. And from the Army Corps perspective, there's a lot of work that's happening in our standards and criteria that will make a lasting impact on the way that we design and construct our facilities. So I think this is a very relevant and important kind of springboard into discussions. So just a quick bio on our presenters. We have Othniel Williams, joined the Corps after completing his degree in architecture from Howard University in 2019. He is an architect at Sacramento District and currently pursuing licensure. During his time as a DA apprentice, he rotated through headquarters, a construction rotation at Hill Air Force Base, and spent 6 months with Searle researching architectural techniques for resiliency. And then we have Helen Hoang, joined the Corps about 2 years ago as an architect for Sacramento District as well. During that time, she spent 6 months with Searle performing research on architectural techniques and addressing resiliency. Helen graduated with an architecture degree from Cal Poly San Luis Obispo in 2019 and is currently pursuing licensure as well. So I am going to turn it over to Othniel and Helen. Over to you.
Hi, so my name is Helen, and today we're going to give a brief overview on resiliency. On the right, you can see the three, the three lead credits, but today we're going to go beyond that in addressing resiliency. Next slide. So what is resiliency? The Resilient Design Institute says that resiliency is not a single solution or an objective perspective. It involves problem solving, balancing both proactivity and reactivity to address these disruptions. One of the first things we looked at during our rotation was the DCAT tool, or the DoD Climate Assessment Tool. You can go to the link on the right after we send out the slides. But basically, you can look through per installation what are the threats to resiliency predicted for 2050 and 2085. The examples for Beale Air Force Base, as you can see, coastal flooding isn't as a big concern as some other things like drought. According to the USACE Guide to Resilience Practices, the concept of resiliency is broken down into 4 elements: prepare, absorb, recover, and adapt. Next slide. So prepare. How can we protect against these threats? So what are these preventative measures to shield against damage to life, health, property, and the ecosystem? So some questions to ask is, what are the current threats in this area that we're building in? What are the unique conditions to consider, both long-term and short-term plans? Next is absorbing, and this is the ability of the building to take a punch, so increasing durability. What materials are the most durable per condition of the site, and how can we build to allow for more human resiliency as well. Next slide. Next is recover. So this is the building's ability to return to its previous state of functionality. So how can we create a building that allows for quicker recovery in terms of, for example, like post COVID-19, daylighting. How can we aid? We can provide faster aid during emergencies, allowing infrastructure to change for quicker recovery. And the last point is adapt, which is a building's ability to be flexible, recovering if the building gets changed forever or that thing gets changed forever. How can we design for the new normal where things are altered forever? How can we build programs that can be easily translated to another type of building? Next slide. So why is all of this important? So the building industry has a huge environmental impact and carbon footprint. So as you can see on the graph on the right from the EPA, both residential and commercial buildings make up large amounts of the electricity consumption, carbon dioxide emissions, and water usage, as well as material use. Additionally, there are massive amounts of natural disasters, especially within the recent years, including wildfire, hurricane, floods, pandemic, terrorism, and an increasing demand for energy that is challenging the way that we build buildings. Additionally, there's terrorism and cyber terrorism, which can cause utility outages, migration due to depletion of resources, diseases, natural disasters, and economic imbalances. And last but not least, buildings are also really expensive. So there is a big economic factor to this as well. Next slide.
So it's important to understand that sustainability and resiliency are not interchangeable terms. So you can see the differences here in the Venn diagram. Sustainability mostly focuses on limiting humanity's impact on the environment and conserving resources for future generations. Resiliency is, again, like has been described, recovering, adapting, absorbing, and preparing for outside threats and forces as they appear. So there are some similarities, obviously: energy, water independence, renewable sources, resource storage, environmental effects, and community support.
So the first topic we're going to talk about is drought. So the causes of drought is due to lack of precipitation over a long period of time, depleting the surface and groundwater. The image on the right is taken from the site that monitors droughts. And as you can see, the western part of the United States is heavily in drought. And developing nations are particularly vulnerable because it also creates economic toll for them, worsen water and food supplies, impacting mass migrations, civil unrest, and also famine. Additionally, drought also causes damage to agriculture, domestic water supply, energy production, public health, and contributing to wildfire. Next slide. So drought being the second most costly form of natural disasters behind hurricanes means that we need to come up with techniques to aid against drought. Some of the techniques is water towers and rain barrels to hold water for cases when it is not available. Hydrophones, which is implemented in Las Vegas, where it could be tacked on to water pipelines to detect for leaks to get that fixed so that water is not wasted. Additionally, use of recycled water and filtration systems could help reduce the load for things that are currently using potable water supplies. Also, low flush toilets could be of use. as well as smart water cisterns that would allow for recharging the groundwater supply, rethinking landscape to such as drought resilient plants, and parking pavement designs that also reduce surface runoff. So on the right is the tower, which is the system that that RTI developed for the Bill and Melinda Gates Foundation, where they had a challenge for people to reinvent the toilet. It's designed to operate completely off-grid without piped water, converting human waste into burning fuel and stored energy, and disinfecting the non-potable water. It operates on less than 5 cents a day and uses electrochemical disinfection rather than chemical and additives. It's designed for the US military because, as you know, 60% of the US military injuries in Iraq and Afghanistan involves personnel supporting base operations. So having something like this would be quite an asset for resiliency within the Army context. Another example is Fort Huachuca that reduced groundwater withdrawals from regional aquifers by over 65% using artificial turfs, water-saving shower heads, waterless urinal fixtures, and reuse of treated effluent. Next slide. So there are a lot of uses of recycled water that isn't tapped into, such as landscape irrigation, fire suppression, industrial processes, dust control on construction sites, wetland restoration, toilet flushing, cooling tower makeup water, recharging the groundwater, and recreational water bodies. So on the right is an image of the Salesforce Tower in San Francisco. Is the largest black water recycling system in a US commercial high-rise. It takes water from sinks, toilets, and drainage from the roof, reducing 76% in water demand, 30,000 gallons every day. That image on the parking lot is like a wastewater holding tank located in the basement, and also the water treating unit on the bottom. Next slide. Another example is the Merrill Center located in Virginia. It reduces water consumption by 80% because it has an on-site shower, laundry facilities that uses 40%, which is rainwater, taking advantage of the current location. The composting toilets also save a great deal of water and sewage rates. The parking is also designed in a way to reduce harmful runoff in the surface, slowing down runoff with gravel and allowing particulates to drop off. It also helps restores the natural habitat of the wetlands that is located nearby. As you can see, there's 3 water storage tanks in the front of the building that is celebrated as part of the design, kind of encouraging water resiliency in this way. So next slide. This is an image of the New York City water towers. This is part of the skyline. It's kind of celebrated. People put art on it, and because this is during the 1880s, indoor plumbing was being replaced from well water to these water storage tanks, and they store about 5,000 to 10,000 gallons of water. They're reserved for emergencies, and they last roughly 30 to 35 years. Built within only 24 hours, takes only 2 to 3 hours to fill with an electric pump. So we could bring back these like older historical technologies to increase water resiliency. Next slide. The next topic we're tackling is flooding. So this is due to rising sea levels and rapid urbanization without planning for water runoff. less green space for that absorption, rising amount of storms and natural disasters. And this causes large loss of lives, economic toll, and damage to property. So the three types of flooding is riverine, which is usually from tropical storms, rain and snowmelt. Coastal, which is caused by sea tidal surges, high winds, cyclones, tsunamis, and other tidal waves. And inland flooding, which is very often and the #1 severe weather killer. This is due to heavy rain in long periods of time in the city. So this is an image on the right is of New York City earlier this summer, where there was a huge flash flood. Neil, can you change to the video? So this is an image of how the flood affects city infrastructure, which is the subway, and can cause panic, especially when it's underground. So. Next slide. So some of these techniques to battle flooding is elevating the building above the flood level, using flood resilient materials, coating sealant waterproofing veneer, raising the HVAC, plumbing, and electrical system above the flood level, installing foundation vents or sump pumps, anchoring the fuel tanks to not pollute the water supply, installing sewer backflow valves, and some of the more conceptual techniques involving floating buildings, building on stilts, kind of having like a sacrificial ground basement that you anticipate that would get flooded, used for parking or storage, and also, again, just wet proofing the building itself. Next slide. Here is an example project in Rotterdam, which is on the right is their first edition, which is a dairy farm, and on the left is a poultry farm. Next slide. This building is integrated where energy production is on the top level with solar energy in the mid-level where the chickens are, where they lay eggs, and the manure is used and processed to grow watercress on the bottom parts as it floats in the water. Rotterdam is kind of known to kind of come up with these inventive solutions that are a little bit different, or because they deal with flooding quite often. So this integrated and like different way of problem solving is important when it comes to resiliency. Next slide. Our next topic is tropical cyclones and tornadoes, and these are large rotating storms with low pressure centers, accompanying with strong winds, thunderstorms with heavy rain. And cyclones are also known as typhoons, hurricanes, and cyclones, or depending on where they're located. The diameter of these hurricanes are several miles large, and some of the largest disasters are caused by them. In contrast, tornadoes are more narrow and they extend from the ground. They occur a lot more often than hurricanes do, but they're not as damaging. They can also be accompanied with sleet and snow, while cyclones are more in tropical areas. And also tornadoes are harder to predict. The image on the right is New Orleans after Hurricane Katrina. Many inhabitants were forced to find safety in areas of higher elevation, such as the city's convention center, after the dam also broke and kind of exacerbated the already dire situation. So as the city remained mostly flooded, fresh water and food also grew scarce, and the sanitation system leaked bacteria and sewage into the floodwaters, causing people to get sick with infections. So like in cases of like cyclones and tornadoes, you also have to think about all the other factors such as waste, energy, water, that also affects the situation because it does not kind of exist in a vacuum. So next slide. Some of these techniques for battling cyclones and tornadoes include obviously also the siting. So building where they are not is the most important, but if we can't choose our site, it's important to build behind a hill to protect against high winds. And if it's near the coast, to raise it on higher ground using similar techniques such as elevating it on pillars or sacrificial ground basement, like talked about before. The shape of the building should be simple, compact, symmetrical, and circular. Not L-shaped because it also that kind of traps wind, and the building should not be more than 3 times its width. When building groups of buildings, they should be in zigzag clusters to prevent wind tunneling, avoiding flat roofs because 30 degrees hip roofs are the best for structurally for these building structures. It is also important to minimize overhangs to less than 18 inches, avoid large fenestration below roof level, having thicker glass that holds the debris in case of breakage, hurricane shutters, safe rooms for tornadoes, and heavier buildings. So on the right, on the bottom, you can see how just by a simple design solution of designing the roof separate from the patio, if you are to have a patio in this location, to design it separately from the main roof structure so that when wind comes underneath and lifts the building, it doesn't pull the whole protective roof off of the building. Next slide. So some examples are these prefabricated circular homes. You can see some of these techniques implemented like pillars, using the ground floor as parking. Next slide. Waterproofing the basement with concrete foundations, having flood vents that allow the free flow of water and so that debris does not get stuck and further damage the building. Also elevating the building above flood level. Next slide.
So for fire and wildfires specifically, the map on the right, you can see it definitely mirrors the drought map that Helen showed earlier in the presentation. Wildfires are increasing in frequency and severity around the world, mostly due to drought and climate change. Other causes include human carelessness. A lot of these fires are caused by human activity. People are doing fireworks or not putting out cigarettes, things like that. And it just contributes to the drought that's already happening. Plants and grasslands are already dry enough without, human activity. So it just creates this huge problem. Development of forests and wildlands is a huge issue. Deforestation, obviously, is going to affect how these wildfires continue to spread and destroy our property, our homes, our communities, and even cause like loss of life. And then also improper forest management, which I'll get into in the next slide, that's also contributing to why we see wildfires spreading so wild and so into all of our neighborhoods and communities, and just affecting the air quality everywhere as well. Just to note some major fires in 2021, it's been a terrible year for wildfires this season. We saw fires in Oregon and California and the States that were huge. And then also worldwide, Turkey, Russia, Canada, and Greece also made headlines for their record-setting wildfires that were devastating to their own respective communities. And just a stat, from January to August of this year, we saw 5,000 more wildfires than the same time period the year before. So this is going to be an increasing issue as climate change worsens, as droughts continue throughout the years. So we really had to figure out how we're going to start a relationship with wildfires that's going to be as less destructive as possible. So some of the wildfire techniques that I've researched, starting with community on a community level, obviously we have to provide relief and create local emergency networks for communities. This includes anything from shelter, different safety factors, egress to different places of shelter, and just knowing what resources are for each community when these things happen. As far as the fire, it's good to allow for succession, allow for these ecosystems to come back on their own, to kind of grow and continue to thrive even after the fires have gone away. For preparation, back to the encroaching on wildlife and deforestation, we have to increase zoning. That's something that I've seen in a lot of my research is zoning has to be stricter. It has to be where you can't build these large communities in areas that are wildfire prone. It just creates a recipe for disaster. A lot of communities will have to evacuate yearly, or you'll see loss of property, loss of housing for a lot of people. And it just creates a large issue for a large amount of people that get displaced. Say for egress and ingress, again, you want to be able to have a way for the communities that are affected to get in and out of the area safely and out of the fire's path. That's something that we can start designing and solidifying now and dispersing to the community. Control invasive flammable species and landscape thinning and prescribed burns. So back to the improper management. All these tactics can be used improperly, and sometimes they are. Sometimes the landscape thinning is for species that actually need to be there. A lot of times people think that just by putting down some trees in the area will, reduce the fuel, so it'll reduce wildfires and the spread. And that's not always the case. Sometimes there are trees that are dead or even just look dead that need to stay in that environment for different reasons. And then also, some trees are inflammable and actually are helping kind of alleviate these wildfires and shouldn't be thinned or cut down. Prescribed burns, as you see in the picture on the right, we use that at a lot of different national parks in the US right now. And in some ways it is effective. It does kind of limit the spread of the wildfires to an extent, but it also should be prescribed, and it should be scientifically proven to eliminate what we don't want to keep growing. Again, we shouldn't just be burning down any species that we see as a threat. There are certain things that we have to take into account, and also how we are going to get rid of the fire when it is time to put it out, and the ways we do that. Avoid above ground power lines. So back to deforestation, when you have these new communities and new developments that are in what used to be forests or woodlands, a lot of times having these above ground power lines will work to their detriment, because when there are wildfires, usually the above ground power lines will go with the trees as well. Once they're knocked down, it can eliminate power for entire communities that are out in the the forest of their land, basically. So when that goes, we have power outages for everyone, and it's harder to get information. It's harder to connect to people who are in trouble and in danger. So it's best to do underground, do solar panels, anything but to have these above ground power lines that will easily be destroyed in these cases. And then obviously we need to be building fire resistant structures, as all designers should be focusing on, for the community, for its residents, for all the inhabitants. It's just what we have to do. Transformation. So the overall, I would say, mindset that we need to adapt to is that some fires that are started naturally are actually necessary, and it's normal. There have been natural fires that have just been started since the beginning of time, and it also just helps to reset the current ecosystems on the planet in different ways. So not all fires should just be stopped, but it's more so about protecting the people and the property, and kind of limiting the damages that can happen because of wildfires. So that's a part of shifting our relationship with wildfires in the future, definitely, as they become more prevalent, unfortunately, due to climate change and the droughts that we're seeing now. And then obviously during, dealing with these wildfires, we have to deal with air quality as well. So severe wildfires, climate change, and pollution in different cities, as well as health concerns, is a huge issue for air quality in the present and in the future. Poor air quality leads to several different respiratory infections, and problems with your health, and also includes death. This is a serious issue, and if you also have pre-existing conditions, this is going to be even worse for you. Roughly 80% of total exposure to particles from wildfires will occur indoors. As this image on the right shows, we spend 90% of our lives indoors, and you can see all the different pollutants that we can be inhaling, just that we're exposed to every day in our buildings. So some of the air quality techniques for resiliency. Obviously, we need to be using the most efficient filtration systems available, especially those in wildfire-prone areas and in large cities. It's just something that we have to start doing. That's a no-brainer. Designed to promote walkability and biking and encourage the use of EVs over gas vehicles. Traffic emissions are one of the biggest contributors to pollution right now. And this push towards EVs is awesome. Promoting walkability, biking, and urban design principles is a great way to kind of get rid of this amount of pollution that we see in our cities. Ventilation, when outdoor air is unpolluted, is also great, and reduce the humidity in buildings as well. Buildings with high humidity are prone to mold and mildew, and they carry viruses and germs in the air a lot longer. So definitely you want to reduce humidity in buildings, especially in times like today. Be mindful of harmful paints, materials, and finishes when designing. These can also contribute to different pollutants and things that you could be inhaling or just being exposed to every day, which is not good for your health. Include plants that trap dust and small air particles. There's actually a study that shows that particulate matter decreases by up to 30% with interior green walls. So the use of green walls and just plants in general is actually a great way, and sometimes an expensive way, to kind of control the different pollutants that find their way in your building. So implementing, I would say, green walls is definitely something that we should see more of, both on the interior and exterior of our buildings. I think that'd be great. not just for resiliency, but just visually as well. That'd be very, very awesome and intriguing to see in different cities. And then lastly, implement and encourage direct air capturing and carbon capturing. So direct air capturing is more so collecting this excess of carbon that's in the air over periods of time. And then carbon capturing is capturing carbon from the source when it's being emitted. So those are the two different terms for you. The International Panel of Climate Change, they suggest that 100 gigatons of carbon is needed to be removed over the next century in order to kind of level out the rising temperatures we see right now. So that's a huge statistic that they've released. And just being a part of that push to keep removing these amounts of carbon in the air will definitely help these rising temperatures, these super hot summers. This past summer was the hottest summer we've had in recorded history. So this is definitely a pressing issue that we have to definitely look into more and encourage the carbon capturing. It's also important to find funding for it. That's another huge issue because right now this idea of carbon capturing and direct air capturing only works when there's funding and it's not very profitable otherwise. So we have to figure out ways to kind of contribute to this and make it so that it's doable for everyone and definitely encourage and promote the plants that are already being built and opening for this. Okay, this is a part of precedent that I found for a building in Thailand. It's actually an open building, so there aren't any doors, but it has an air purification system powered partly by solar panels and has air purifying plants with dust retention capabilities and air curtains that kind of blow in fresh air into the building and like kind of keep out the air that is outside in the street, which I thought was a great idea. And it's really interesting seeing these open structures and how they still kind of create this pocket of clean air. So it's very efficient in that regard. And I think a lot of designs in like Thailand, Japan, China, different areas like that have amazing concepts and resilient architecture for air quality in general that we could be learning from. You'll see a lot of those in our document as well. And I want to shift to the document quickly. So you can see, so me and Helen over the fall have been working on this document, which kind of outlines all the different resilient practices for different topics. It's called a pattern language for a more resilient future. It features more in-depth understandings of all the topics that we've covered today. And it also will touch on energy, space, anti-terrorism, and earthquakes as it relates to resilience. Each topic will feature the introduction to this topic as far as what it is and the problem with that. And also will show resources that we found helpful when designing and strategies and precedents that you can look into when you're designing your own structures, your own disciplines. It's very helpful, and I've looked at it several times on my own when coming up with my my designs so far. You can also see just how lengthy and how in depth it goes into. And there are amazing diagrams in here that Helen has illustrated. So please take a look when you can. We worked really hard on it, and it's definitely helpful. Back to the presentation, just to close it out. I think we can all agree that designing with resiliency in mind allows the Army operate, prepare, absorb, recover, and adapt it, all the threats that it may face. Um, Obviously, a great example is Tyndall Air Force Base, um, which was hit by Hurricane Michael. And it was said that 95% of its structures were severely damaged or destroyed, and there's an estimated billions of dollars in damages. So today, Tyndall is doing great, and they're on the process of recovering and rebuilding for the future of its installation. But as we build strong, we should also think about building resilient. And that's what we wanted to kind of focus on today and push forward for the future of the Army. So that concludes our presentation. And we'd love to hear any questions, any comments at this time.
Daniel, Helen, thank you so much for the presentation. I'm looking through the chat and I'm not seeing any questions. There's a good resource from Kathleen. She dropped in just a note about routine flash flooding. How in Arizona, I believe there's some good resources if you look at their Phoenix Metro design standards. And yeah, I'm not seeing any questions here at the time.
I
Yeah,
think
but thank you.
Timothy said, is the draft report available? Yeah, I think we will send it out to everyone as well with the presentation slides.
Yes, so what I'll do is we have a Teams folder that I could drop this into, so that could be kind of a resource. I'll drop it in with where all these presentations, the slides, and also the recordings will be placed. So please take a look there for it. I've been going through it. I think it's a pretty good resource to use in terms of kind of getting situated in your understanding of resiliency, because I think it's still fairly a new topic to people. And I think one of the good slides that you had here was what's the difference between sustainability and resiliency. And I think a lot of people have had that struggle. So appreciate having those kinds of definitions and stuff like that. Thank you.
You
All
guys
right.
are awesome. I had really a lot of fun working with them all summer. We had lots of meetings and brainstorms, and they were awesome. This is Annette.
I think Riza asked if there were any resilience specific UFC or codes. In the draft report, there's sections where there's references to specific UFCs and other applicable codes in one of the chapters at the beginning.
And also, to add to that, I believe there's a couple of other guide specs and UFCs that are being developed at this moment. I know there's one that's going to be called something along the lines of critical infrastructure. And I think that's covering a lot of the electrical, a lot of the electrical discipline concerns in terms of resiliency. And we have more than like 24 resiliency focused efforts in updating current UFC and UFGSs. So you won't necessarily see resiliency as a standalone UFC or UFGS. That we probably will, but a lot of times we will be incorporating resiliency into our existing documents to make our standards and our criterias more resilient. So I think that's the strategy and the approach that we've been taking as Tri-Service.
One more
All right.
thing I'd like to bring up is that as like our introduction, resiliency isn't just a simple solution. So our conclusion, kind of like at the end of this rotation, was that it was important for each project for the design team to kind of examine everything and kind of determine what the risks, the largest risks are, and kind of weigh their options, because there's like certain things like that would be helpful to resilience with droughts, but could be worsening like resiliency towards like another topic. So it's kind of up to also the designer.
Yeah.
All right. Yeah, really appreciate it, Othniel and Helen. Really appreciate it. This was a great presentation, and I've learned a lot, and I really appreciate providing this info for everybody. So thank you so much for your presentation, and have a great day, everybody.